Allow me first, the word SMR, small modular reactor, we heard a lot about it in the last 10 years, but recently became more and more pronounced. And SMR, small modular reactor, it is part of the energy mix to help to overcome the green gases and the help the environment. So that's what is the background for the SMR, part of the strategy for nuclear mix. I would like to start by spending just 2 minutes explaining a little bit of the development and the history and where we are now. Then I'll move to SMR. The first nuclear power station was built and developed, delivered power in 1957. That was called the Hall in Northwest. And at that time, the UK always used gas technology and graphite as moderator. Most of the world, like America and Europe, has concentrated more on the water technology and having control rods for the power control. If you look at it, Russia as well followed the same line of water technology, but used some graphite in some of its moderators. And if we look at the Canadian, they had heavy water reactors, which had used heavy water. The power size of these power stations, it varied from 300 to 600 to 1,000. But 1,000 megawatt became almost the standard size. The 1,000 megawatt electric, which is nearly 3,000, more than 3,000 thermal power per reactors. And that became the standard. And over the last 70 years of operation, actually 65 plus, we had 3 major accidents, which is the 3 Mile Island, which is PWR in America, 1979, Chernobyl, 1986, 87, sometimes I forget the exact date. And the last one was, of course, Fukushima. The first one they talked about, in my opinion, was not an operator error, was a designer developing the operating instruction correctly. But I'm happy to take any question from you afterwards about the 3 major accidents and how is that fit into the development of nuclear power. So please, I'll leave that open for you to ask about if you wish. After a long time and a lot of discussion within the nuclear industry, people start to realize perhaps the small is very beautiful after all. And a small modular reactor maybe is better than large ones for a number of reasons. You know, the most obvious one was the grid stability, and you need a grid for each country, a national grid, if you were to deliver such huge amount of electricity and distribute it nationally. And the other part, of course, is economics and the time it takes to build them and how much capital costs you need for it. So SMR became, as I said, more beautiful and more attractive for a number of reasons, you know. And the other one as well, as we'll discuss it later on, is the industrial relation. And in the 1970s, in the gas-cooled reactor, we had huge delays in the development of and completion of the gas-cooled reactors because some industrial labor disputes and strikes on site, because everything was done on site. I will move now to the SMR itself. There was a lot of discussion and a lot of countries developed SMR, and hence, what is the definition of SMR? What is it? So the IAEA took it in themselves in Vienna in discussion with member states and came with some kind of simple outline of SMR, small modular reactor. It should be around or not more than 300 megawatt electric, which is about 1,000 megawatt thermal. It should be able to add a modular to it and use the existing infrastructure for the station, so you don't need a new infrastructure. It should be designed for commercial operation, and some of it can be used for district heating, desalination, and other application as well. That is sort of the semi-official definition of SMR, because this was huge, a lot of development around the world at the moment of SMR. And what are the types of SMR? I'm just summarizing very briefly. There's light water reactor, similar to the PWR, and that has its advantage in terms of proven technology, if I call it that way. There are fast neutral reactors, which has its advantage, and molten salt reactor, for example, which again use fast neutrons. And there is, of course, high temperature gas cooled reactors with the graphite as its moderator. I'm giving you just a flavor of that. There are so many of them. Some are advantages. The advantage of the molten salt reactor is that it can be smaller, and you might not need to refuel it at all, maybe for lifetime, 25 years. But of course, it uses about 19% enriched uranium for in the molten salt. Let's talk about safety. The small modular reactors will have much less, if I call it source term within it, or in other words, the potential consequences is much smaller. It has, most of it operate at lower pressure, instead of the PWR, which operate very high, 150 bars or thereabout. It is implemented the natural process of natural circulation for heat removal. So if anything like Fukushima would happen, you almost can walk away and leave the natural circulation to remove the decay heat with no worries about it. It helped them to eliminate number of the moving parts, like the big pumps and so on, and that helped in eliminating by design some of the accident we used to look at for the large nuclear power plant. Yeah. The other advantage as well, it can be manufactured on site, not on site, on the factory, and transported to site. So the QA and clean conditions will be almost much more assured than working on site as such. And that will help significantly in terms of reducing potential error or mistakes on site or difficulties. It applies, which is the same like large reactor, negative feedback, so it can shut itself down or reduces power generation if the temperature increase. And is, as I said to you, this is overall became attractive. The point which is still at dispute at the moment in terms of the risk from the site, because you used to assess the risk, which is the potential accident frequency by the consequences to give us the risk on the site. Adding more and more to it, it's almost you are increasing the risk by salami slices, if you know what I mean by that. The first one, the risk would be much less on site, but by the time you add the module 2, 3, 4, and 5, the risk from the site would increase, of course. But that is at the moment being discussed with the regulators as part of the licensing process, which I'll come to it as well later on. Security. Security, I look at as two parts or two elements or two categories. The one which we all know, which is security by intelligence, policing, and protection, physical protection. The other part of the security is security by design. As we carry out investigation of the vital areas of the safety systems. This came about after the 3 Mile Island, after the September the 11th accident, attack by airplanes, and we looked at possibility of intruder in terms of somebody escapes the bigger picture of security and already working in the plant, for example. What kind of damage would it do? And I will give you a very quick example. Like, as you know, all of you, that we have redundancy and diversity in the safety system. Say, for example, the heat removal system has got a redundancy. You might find 3 pumps, each 50%. So only 2 you need to operate and 1 standby to help you if 1 will not function. Diversity, the 3 pumps will be different designs, so we avoid any common cause failure that the 3 of them will go at the same time. But we discovered when we looked at some of the layout of the plants that, for example, these 3 pumps are put in the same room. And if they are in the same room, if there is an intruder, then he will eliminate the emergency heat removal system in 1 go. And they will be in difficulty like what Fukushima has suffered from. So a lot of security work has been carried out to identify the vital area from safety point of view in the plant. And we separate them So if there is any intruder, they cannot remove everything in one go, but will give time for the people to be aware of what's happening in their own plants. That's what we call security by design. That's the best example to give you in terms of vital area identification and security by design. I will talk about the regulation now. Regulation, as I mentioned to you, it's the regulators are facing some challenging points because it's a new technology. It hasn't been proven like the light water reactor and PWR, which has been operating for many, many years. There are already 440 nuclear plants in the world. They can draw in their experience from it. Now, the new technology didn't have the opportunity of going through the teasing problem and solving the difficult issues, as well as the point I mentioned earlier about the risk from the site. The risk from the site initially might appear to be very small, but by time, if you keep adding more and more modulars, then the risk from the site, of course, will increase. So there are a lot of discussion at the moment, and I'll come to the IAEA, as Ian just mentioned earlier, IAEA safety standard. They're looking at reviewing some of the safety guides because they were more water technology oriented and trying to make it technology neutral as possible, but is difficult. You can do that at the level of the safety requirement, but when you come down to the safety guides, you have to be more specific. But there's a lot of work and review at the moment within the IAEA on this area. And you have to remember as well, at least for the UK, the word evidence is very important word, because we ask the potential operator or the organization ask for a license, what evidence do you have about your safety of your plant? And evidence usually is translated on experimental work into operating experience and so on and so on. So it is in discussion at the moment with the operators, with the regulators in terms of how to approach regulating SMR. Bearing in mind, if you apply the principle of proportionality, then the amount of work required to license SMR much, much less than a big plant. So it's a difficult issue, applying principle proportionality approach and graded approach, and yet you need to be 100% sure that plant is safe. Yeah, I'll talk about the economics again very briefly for a second. The economics maybe it is it's a clear picture. The amount of capital investment you needed is much less than a big plant. Big plant, as well as being large amount of capital you needed upfront, the number of years to recover your money was quite significant. And if there is any political changes in the horizon in a specific country, then you're not sure if you recover your costs or not. Take, for example, Germany, best example. They decided to shut their plant much earlier because of Fukushima accident. So the investors became very uncomfortable with the prospect of putting all this money up front and not knowing what might happen in 10 years or 20 years. And yet the plant has got plenty of life left in it. And the other good economics as well is the fact that you can build it in the factory. It is much more controlled, and you can produce modular, and the component can be assembled much quicker, and you just put it in a, how shall I say, big lorry, you know, or big transporter and transport it to site. So, and the fact that you can produce number of them. The difficulty with the large reactors as well, we used to build one every 10 years, every 20 years. Their knowledge and investment has already almost became obsolete. I don't mean it in a bad way, but you know what I mean. Things has moved on. While if you have SMR, you can produce 5, 10, 20 from the production line, and hence the cost per unit will be much less than what it would have been. The fact that you can actually use the existing infrastructure of the existing power station, say for example, an old coal power station has been shut down. At the moment we're saying leave all the infrastructure around, because if this site were to be allowed by the regulators to be a nuclear site, then It's just simply putting the reactor and use the existing infrastructure. So this is another advantage. The more advantage is that you don't need large grid, so you can go to remote location and build small ones. So you can see a lot of attraction factors helping the SMR economically and safety and security as well. One area for security I didn't mention as well, or safeguard, if we should call it this way, is the fact that most of the SMR, or at least the some I'm aware of, you can build them under the ground. So they're, in terms of extra protection, they are not in the surface of the fields you're building in, for example. Now, if there is any operating SMR around the world, yes, there are. I think 1, 2, 3, 4, 6 I came across when I was looking through them. There are 3 of them in Russia, 11 megawatt, 35 megawatt, and 50 megawatt. All of them applying the light water technology in terms of the cooling and the control system and so on. There is another one, pressurized heavy water reactor in India, 220 megawatt. Sorry, I beg your pardon, a heavy water reactor in India, 220 megawatt. And the last one is 300 megawatt. It just so happened fitted the size in Pakistan, Chashma 3. It is a Chinese design, but the design was originally meant to be 300 megawatt. It didn't really mean to be within the SMR boundary, but it's just so happened it fitted in the definition of SMR. The other area I would like just touch upon quickly before I get question, what's happening in the UK? The UK, I was sitting previously, now I'm not member of it, but I was member of the advisory board for the nuclear innovation for the government body. And during this period, we have strongly recommended that SMR, not just in terms of meeting the challenges of environmental conditions, but in terms of a good business for UK Limited. Because the UK, historically, we were way ahead of the rest of the world in the 90s, until all the nuclear power, until the nuclear industry was privatized, and then everything went down in the hands of the accountant. I hope no accountant sitting in here, not to take it. So it would be good for the UK Limited as such to have its own design. UK Limited have its own capability internally, and be able to, for example, take Africa. There's huge demand in Africa for nuclear power plant SMR, because again, back to the national grid, you need a national grid and investment and so on and so on and so on. So we made the case very strongly, and well, actually the case is the wrong word. We were asking the government, you should not carry on sitting on the fence anymore. Either yes or no. You cannot carry on dragging the issue for so long. And we recommended that Royce should be taking the lead in that topic as such, in conjunction with the advanced manufacturing facility in Sheffield as the base for manufacturing any future SMR. And as you know, all from the news, there has been investment during that time from the previous chancellor, about 200 million. And then more investment from the UK government now. And even, I believe there is some investment, I might be wrong, but I heard Qatar is putting some money at Rolls-Royce for the SMR work. I might be wrong, but I saw there was some kind of foreign investment as well. Rolls-Royce went ahead with it, and they already submitted a design, so have completed the design to the ONR, the UK regulators, to carry on a review of the safety review of that first SMR will be in the UK. And the idea is it should be built and operating by 2029, 7 years from now. The likely site will be Trawsfynydd, North Wales, or maybe in a other location, but I heard Trawsfynydd might be the first site because the infrastructure is there from the 2 existing Magnus reactor, which have already been shut down. So the UK is quite active there, and the advanced manufacturing facility in Sheffield has been doing a lot of fantastic work. When I did see some of it, I was absolutely amazed how the engineering and technology have advanced in terms of manufacturing. So that's the bigger picture for the UK, for the internationally, and so on. And I'll touch upon internationally very quickly. Canada is leading the way because of the remote locations, and they have signed an agreement with Westinghouse, with potential SMR, and signed another agreement, I believe, for maybe for molten core reactor with the, I'm trying to remember the name of the company now. So Canada putting a lot of effort and a lot of money and investment in terms of trying to be the first to build SMR, the truly SMR, compared to the ones that's already built in the West. And the US is the same. The DOE, Department of Energy, putting a lot of grants, more than £1 billion, in terms of like for the small organization to be active in SMR. And the other application SMR will be very interesting, and I'm actually an advisor for the company. It is a company called Core Power to put a small SMR on container ships. So transporting, getting away with diesel completely for the shipping industry, and have a small SMR on the ship. In terms of, and the size of that, I think is 1.5 meter size of the reactor, 1.5 meter size, and will be put in the container ships, exactly in the middle, in the bottom, protected. It's still early days, but they're leading the way in terms of having nuclear powered commercial ships. And I'm happy to take any questions. I just gave you a flavor of everything, and I'm opening any questions you wish. It's up to you now.
Okay, thank you very much, Mamdouh. I'll kick off. I have to say, I've been doing some work for IAA myself on small modular reactors recently, and I was in a workshop, online workshop with many people, and I was surprised at the reservations that many regulators had with respect to small modular reactors. I mean, I think many of them felt that there was a lot of hype going on, and that there were many problems yet to be addressed or even really thought about from their point of view. So I think, you know, one has to be a little skeptical. I mean, I share your enthusiasm, but I think I am rather more skeptical about the prospects. And I mean, just introducing any new reactor will introduce a whole new raft of safety issues. I mean, one of the things that was mentioned, for instance, was that we've been used to running large reactors, each with their own control room. With small modular reactors, it's often the case that they talk about running 5 or 6 reactors with a single control room.
Yes. Yes.
You know, and you can imagine the scope for confusion there. You know, which pump is this? Is it number 1, number 2? Which reactor are we talking about? You know, that this is a sure way for accidents, and accidents have happened. Yes. Because of people confusing, you know, getting the wrong pump, turning the wrong valve because they thought it was on a different reactor. So, you know, that's just one example. And
I will join you for a second, because I'm in the same level of talk. I'm a safety man. I agree with you. Even I'll give you even more worse example if I may. I'm enthusiastic about it, but at the same time, you have to be fair, you know.
Yes.
Like one of them, the fundamental principle of defense in depths. I don't mean diversity or redundancy. The level 1, level 2, level 3 defense in depths, as defined by the IAEA. A lot of this SMR are finding it difficult to achieve, because they rely on the same equipment doing more than one job to make it small. And by definition, if you do that, the common cause, that is not a safety system. If you're using it all the time for something else, and then you're switching it off, then question marks. Yeah, I'm just giving you one question mark, which I have in mind. The other question mark is evidence. What are the experimental evidence that the system, the new technology is working? So although I'm very much in favor of it, but I ask all this difficult question myself. And I'm not shy from asking it. It's the other way around. It's our job to ask these very difficult questions.
Yeah. Okay. Anyway, I got lots more, but I'm happy for anybody. I'd like to give somebody else a chance. Colin Megson, you're on mute.
Oh, yes, thanks very much. I just wanted to take up this point about the 300 megawatt being the sort of limitation for small modular reactors, because the Rolls-Royce small modular reactor is
450. Yeah, I know.
470, yeah.
Yeah.
And the way they arrived at that, if you listen to Tom Sampson, is they started with the outside diameter of any of the modules could be shipped by road. But then when they worked back inwards, they ended up with a core size, and the core size had ended up being 470 megawatt electrical. So it is a small modular reactor. But the other thing is this aspect about the safety. Both the Rolls-Royce one and the GE Hitachi BWRX-300 are Gen 3 Plus, and talk about being walkaway safe. So the fact that people can sort of twiddle buttons if they're controlling 2 or 3 reactors and cause all sorts of problems, I would imagine should not be an issue. And then we've got NewScale, who have 12 modules within their power plants, up to 12 modules, and that's all controlled from one control room, and they've actually mocked that up completely and tried and tested it. So I don't see that being a particular safety issue. Would you care to comment on that?
Yes, indeed. I will comment. To have one control system for multiple units is almost defeating the object of defense in depth. That's my opinion. You might argue that I'm still a bit theoretical and more stuck in the past with what we know about safety. But they're making NewScale making the case that the way they're handling it should be pretty safe. I am not sure. I have not seen it. It will be interesting to see the control system, and it'll be interesting to see how they can guarantee a computerized system that it will not actually. We know all the computer system. There is occasionally problems with it. I'm not convinced about that at all. And I would like to add more comments as well about the walk away from the reactor when it shut down. Yes, you have natural circulation in principle. Use the word principle on paper. It will remove the heat, but you might have discontinuity in terms of you generate too much bubble in the process, and then hence the loop of the natural circulation will be broken. Broken, I don't mean broken, leaking, broken in terms of continuity of the heat removal. So there are a lot of issues, and the word evidence. The regulators and the industry overall need to provide a lot more evidence that their innovative approach is working. I am not defending it. It's more questions to everybody.
Okay. Could I just make the comment that the GE Hitachi BWRX-300 has natural circulation, unlike the PWRs that Rolls-Royce has, and they use what they term a chimney to extend the length of the reactor pressure vessel, and that's been a tried and tested item that they've already used many years ago I can't remember which country it was in. Maybe in the Netherlands or something like that. So that it is a sort of tried and tested situation regarding natural circulation.
Colin, I agree with you. When I refer to some problem, I don't mean every design have the same problem, but some of them, as you said, the BWR, the 300 BWR, did do a lot of experimental work as well. And I have to refer to the Chinese as well. When the Chinese started 15 years ago, and they wanted to come with their own 1,000 megawatt. They have done huge amount of experimental work. I have seen the evidence of the experimental work, because when I was at the IEA, the Chinese came and asked us to look at the 1,000 megawatt design in relation to the IEA safety standard, if it's meeting the requirements or not. And the first question we asked them, what experimental evidence you have? And we have seen they have done a lot of experimental work to support and give confidence that their design will actually function. So yes, it depends on the country, it depends on the design. I agree with you completely. When I refer to specific problem, I don't mean all of them share the same problem.
Okay, thank you very much, Colin. John Finney, you've got a question?
Yeah, it's a fairly boring one. Construction times. Okay, these things are manufactured and assembled on site. would you like to compare the time it takes from agreeing to actually build one to actually generating electricity? Because, you know, obviously, if one is talking about nuclear power as one way of trying to reduce the global warming problem, by the time you built your big nuclear reactor, it's too bloody late. What's the timing for, you know, if I say in my back garden we can start building one tomorrow, how long before I generate electricity?
According to Rolls-Royce, once they have the approval ONR to proceed with the construction, and because the advanced manufacturing facilities in Sheffield did a lot of experimental testing on how to manufacture the different components, they saying we should be able to generate power within 4 to 5 years.
You say that's what Rolls-Royce say. What do you say?
What I'm saying, if the classic problem with the nuclear power plant is they started, if you look at Finland, they started construction, the EP, the French design and the German design before it was fully, how shall I say, not fully designed. It's designed, but was never fully examined in details. And as a result, the Finnish plant, it took twice the amount of time to build. What's it, 15 years? Unbelievable. So the answer to your question, anybody who's coming with SMR, unless they have the proper design, completely sealed and signed and approved before going to the regulator, then it will be a long process again.
Okay, thank you.
I agree with you. I mean, that's why the answer is, I have seen it myself when I first started in 1975 in a gas-cooled reactor in Dungeness. Right? I mean, here Ian is laughing about it. I don't know what to say to you. I mean, it's just sad story from day to day it was. And I was my first job. And I asked myself, what the hell am I doing here? You know, it looks like disaster waiting to happen all the time. But if you start a project without everything in place, huge delays will happen.
Yeah. I remember many years ago when the Finnish reactor, they started building it, and we were absolutely assured that there would be no overrun at all on the building time of that. And look what happened.
Yeah, I'll give you some more, one point for a second, if I may, Ian, just comment on the Finnish reactor, because I'm not going to you the name of the solicitor company. It's a very famous company. They came to me, will I be a witness in the litigation case between Finland and Arriva about who should be responsible for paying the delays. But it was very interesting. I looked at it, but Lloyd register, which I was the director at the time, they said, no, we're not going to involve any of this, despite the fact that we're paying a lot of money. They said, we're not taking anything like that. We're not going to be part of any law case, you know, a case in court, and then people will sue Lloyd themselves after that. Yeah. So that's for you, John, about Finland.
Okay, thank you very much, Mamdouh, and thank you, John. Eric, did you have a question?
Yes, indeed. I think we should look at this issue of many of small reactors in a much wider context. If they are just going to produce 1% of world energy in, say, 20 or 30 years' time, then it's not really interesting. It's a small niche, and let that niche manage itself. What you want is to say, is the question, can we get nuclear energy to form a significant part of total world energy in 2050, when we should be off gas and all fossil? That means you're going to have many reactors. And then the model is not the model of getting a site and building a reactor. It's much more like the problem of air travel. You have a few companies making planes, and there's a very good system of judging the quality of planes, and it's constantly being improved. New checks are being built in, and existing planes are being changed to conform to those rules. So you have the equipment, you just buy it, and it's an international market. At the moment, there are two main manufacturers, but for smaller planes, there are some more. The second thing is, you make airfields, which would correspond to the sites, and you say under what conditions can what planes land on those airfields. And that separates the whole issue of regulation. You have regulation on the planes, which is well done by special by organizations which know what they're doing and which do not belong to one particular national authority, not in practice. And you have other people who judge when can it be safe, in what location, but then you don't worry about the plane. For cars, we have the same system. And I think we should be looking at a system that you have mass industrial production of the of the equipment, and you have a separate process by which people say, oh, I'd like to have this one in my back garden. We approve the back garden and we can put the system in it. I haven't seen that approach anywhere in the nuclear world so far. Up to now, it's all been one-off castle building and not mass production and siting, with production and siting being clearly separated.
You are right. If I may comment, I'll take the first one. Rolls-Royce and Sheffield Advanced Manufacturing have just announced, I think today or yesterday, the advanced manufacturing facilities in Sheffield will be making components for equivalent 16 units, the mass production we're talking about. In terms of somebody to judge if the equipment made at the time is correct or not, or is still valid or not, like the aeroplane, yes, we have that in the periodic safety review. Periodic safety review by the IAEA is essential, and in the UK is essential, that every 10 years you must review every incident in your station, you must review all the equipment, and you must check them against today's standard, not 10 years ago. And if today's standard is showing deficiency, and then you have to correct it with backfit to meet today's standard. If you can, sometimes you cannot. But today's standard is the norm now, that every 10 years you have to review your plant and show it is still capable and maintain safety up to now. The only country in the world objecting to that and give me personally a hell of time in IAEA when I was there was America. They refused to have a periodic safety review based on IAEA safety standard and IAEA approach, because they said they built it at the time and the lawyers are waiting to challenge us. How can you try to compare it to today's standard, which didn't exist 10 years ago? It was all legal issues for them in the US, and they refused to apply it. They're applying something equivalent, but not what we would have said is the best way to deal with the long-term effect and the advances in knowledge. Because advances in knowledge should not be stopped, but should be implemented in the old plant as much as possible. So I agree with that completely. And as far as mass production, yes. And the last point about international regulators, if I call it this way, there has been a lot of times discussion of having a standard regulatory approach. So if one plant is approved by one regulator, say for example, US, that was led by the US, then the UK should not ask you too many questions, to just take it and use it, as long as they check the site is suitable for it or not. It didn't fly. Most countries in the world said, no, we'd like to do our own examination. We'll use the benefit from your knowledge and we'll take it into account. But at the end of the day, we cannot take it blindly that this reactor has been licensed in the US, can be licensed, for example, in the UK or United Arab Emirates or Abu Dhabi or anything like that. We would like to still do our own checks and take into account some local conditions, not necessarily technical, but maybe political and maybe social as well. So everything you said, you're absolutely correct. And there's a number of areas we're covering and some of areas still difficult to proceed with it.
Thank you. Colin, did you have a follow-up question?
Well, I just wanted to make the point that I don't know if people are aware, but Rolls-Royce have been making small reactors for 60 years now. I worked for them in the 60s when we were still using slide rules. So when they say 4 years now for a delivery period, I think you can be pretty sure that they'll be able to meet that within a short time of building the first 1, 2, 3 reactors.
Colin, I hope you're right. I strongly supporting that UK should be lead again in SMR, and we should be able to export it to Africa safely, on time.
So on the question of exports, I mean, this issue of every country having its own set of regulations is a real hindrance to exports. And if you're going to build a huge factory to turn out these things, then you're going to need exports because the market at home will dry up pretty quickly.
Yes, 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 yes.
And of course, the other thing is there are going to be plenty of competitors. There's lots of people, already 2 or 3 people out there which are quite well advanced. So
yes.
the potential for export sales could well be quite limited.
Well, the regulators were absolutely correct, and that's why SMR, at least the World Nuclear Association, trying to get people together to agree in about certain approaches to the regulation. However, having said all that, if I look at Abu Dhabi, which I know very well, because the head of the regulator there is ex-colleague, well, no, ex is wrong word, a very close colleague. They have developed, they use mainly all the Korean approach, but they topped it up by independent reviews. Okay, so the independent reviews were not questioning a lot of the, shall I call it, bread and butter, which we know it worked, but was questioning the innovative approach and how you deal with accident scenario, for example, on the desert, which is fair enough. You need more equipment in the desert, more this, more that. So it became more or less like a site-specific rather than questioning the fundamentals of it. But you are absolutely correct about that. It's an issue. And I remember very clearly we had a big meeting in Paris, maybe 2010, 12 years ago. And the regulators were there. You might know Mike
Waitman.
Yeah, that's right. Mike Waitman was there. And I was the IEA, so I was not wearing the regulator's hat at the time. And it was quite a lot of debate between him and the French and the Americans. I mean, like Americans pushing very hard to say, we approved it, why the hell you European looking at it again? And you can imagine the French jumping up and down and insisting speaking in French. So I will stop there.
Christopher.
Is it Brian? Brian, I think.
Brian.
Yes, can I ask, could you enlarge a little more on the brief reference you made to China? Because in terms of mass production and their record in terms of producing nuclear power plants is certainly something that's that is quite outstanding. It has been hitherto, but I'd like to link it also with this question of the potential in African countries, because we've been working on the subject of smart villages rather than smart cities, and in particular the use of renewables, which of course make energy availability as a catalyst for development much more attractive than it ever has been in the past. So the question is, what about cost considerations of renewables versus SMRs?
Well, I will tell you about China first, and I have my views about China because I have dealt with them, and they are very clever in sucking all the knowledge in anybody's head talking to them.
Sure.
They're very clever. I gave them that. And at some point, we decided we're not going to answer any questions because we're letting out a lot more knowledge from our heads. You know, in China, how can I say, sorry, my English is authoritarian state. They can go ahead regardless of the locals' objections. I don't think there was any local objection, but I sit an advisory board for an Italian company which is doing a lot of safety analysis. I knew them since they were a student, PhD, so I knew them for many, many years, doing a lot of safety analysis work and computer analysis for China and supporting them. And the owner of that company is called Nine. He said, I wish of Europe like China. I said, what do you mean? He said, I be there in a visit. I go back after a year and everything is finished.
Yeah.
You're not, still not debating it in a committee, you know. I just wish if Europe is behaving like China in this respect. So you are right about China getting away with it immediately. As far as Africa is concerned, I personally believe for Africa and the Middle East, say Egypt, for example, beside nuclear and so on, but Egypt is a very large country. Solar is fundamental in terms of energy mix for them. is so fundamental. And I believe Norway has only recently made an agreement for about £3 billion with Egypt to produce what they call, I'll use the same terminology, green hydrogen using solar energy on the Red Sea. So for the rest of Africa, in the village community or town community, if you can use renewable, that is, nothing can beat it. Nothing can beat it. The advantage of SMR is some remote parts like Canada. That's why Canada is very interested in SMR. I mean, it's already cold or snow all the year round, and they need a small reactor for a small community. And remember, one of the Westinghouse SMR is only, I think it's 3 megawatts, very small, but it will get a town or a village completely up to speed and the industry up to speed. Africa interested in some of the African countries, the SMR, because the prestige and future technology. But if I were them, if I was in charge of any African country, I say use solar, for God's sake, you know.
Okay. Christopher, did you have a question?
Well, I just wanted to make a comment on the whole of this discussion. I think there's been a lot of focus on how safe one small modular reactor can be made, and there's been much less discussion on how a system consisting of thousands of small modular reactors can be made. And if one looks at other bits of moderately high technology in which the process is divided up into a very large number of small modules, the sorts of accidents that cause the real problem are not, on the whole, Fukushima or 3 Mile Island type accidents. They're accidents relating to the individuals who are given responsibility in operating the system. And I think that it's going to be very difficult in a world in which nuclear power came to provide, shall we say, 20% of the total energy supply for the world, where we're talking about several thousand standard 3 gigawatt E reactors to provide that sort of fraction of the total power, and getting the number of experts to run that system is going to be the really limiting factor, in the same way as the availability of a safe transport system on which, say, 20% of the driving power is provided by cars. Individual cars can be made very safe, but communities in which transport is to a significant extent provided by cars, the safety of the system is determined by an ensemble of operators, some of whom are much less experienced than the best. And the death rate from cars is due to mechanical or electrical problems in the car is negligible compared with the death rate due to drivers behaving badly. And I think that that's going to be the real limiting factor in a system in which SMRs contribute a substantial fraction of the total generating capacity required. And I think that one way of trying to transfer experience on individual cars up to transport systems in which there are a large number of individuals of very variable competence is required. And on the whole, people who take decisions about that tend to go on the basis of global safety figures and or global economic figures. And I think that I would take quite a lot of convincing that gigawatt electrical supplied, that one large 3 gigawatt reactor is not significantly cheaper than the equivalent number of small modular reactors.
It is, you are right. The technology transfer and the knowledge is essential. And the large reactor, any country embarking on the large reactor, they spend a lot of effort and time and money in training their own people, including Abu Dhabi, for example. They have unlimited amount of money, if I call it this way, and they train their people everywhere around the world, and the potential operator and the designers and so on. So you need a huge investment in the human side and operator side. But one of the arguments to SMR, if I may start another line now, is you don't need all these operators. You need to have some knowledge, but you don't need to know all that. If anything, some of them, I'm not going to tell you which vendor, they're saying we can operate it remotely from London. You just need one to keep the gate shut and open, and just we operate it for them from London. But of course, this is madness in my opinion, because to treat something like nuclear as a black box is very dangerous for the country you're dealing with. So I'm just giving you an example about the thinking. We don't need an operator in this country. For example, in the middle of the desert, we can run it from London. Just need somebody, a gatekeeper. That's all we need. But I mean, that is like a big joke to me. Sorry. Yeah, I'll stop here, and I say it. But not get dragged in politics and personal opinion about some of these people. I'll go back to Ian.
What do you think about this dispersal? If they're going to have thousands of reactors spread, some of them in quite remote places, isn't there a kind of security issue and a safeguards issue associated with that? You're going to need a lot of security people to look after these places.
Yes. You're right about that. But again, some of the argument I heard, like the molten salt reactor, which is very small, that the uranium itself is part of the molten fluid, and the fluids got solidified around 350 degrees C. So if the reactor is shut and anybody want to move it, everything is absolutely solid inside it. You can do nothing about getting the uranium out. I'm talking about the bomb now, but about dirty bomb is different situation, because all you need just messy up radioactive stuff. It doesn't have to be even uranium, and just put it in a dirty bomb. So yes, security issue is a major one. I safeguard and maybe less critical as safety as the security one. But when I mean by safeguard, I mean bomb. You know what I mean? But security, I mean dirty bomb.
Yeah. That's what I was thinking. You basically more targets.
Yes.
You've got more targets for people to attack.
Yes. We're still a long way from what people are hoping for at the moment, but it's almost like step by step. The main attraction is remote location, no national grid, less investment, modular, built in a factory, transported in a train, and installed very quickly. I'm just giving you the advantage of them. And operators as such, as long as there is enough security, you can even operate it remotely, which I don't believe that, but that's some of the argument. The negative is very clear. Security, safety, still, and so on and so on. Yeah.
Colin, you've still got your hand up. Are you still?
Yes, I mean, why don't we just concentrate on this country to start with? All the regulations are in place in this country for safety and security. And we've not talked about cost yet, but if you look at the overnight capital cost for Rolls-Royce small modular reactor, it would come in at half the cost of the big EPRs that are being made at Hinkley Point C and proposed for Sizewell. And also, they could be in position in 4 years, as opposed to 8 or 10 years for the big nuclear reactors. And it would be feasible from 2030 onwards to scale up the production from what Rolls-Royce are proposing, which is they're proposing that they are establishing factories to build 2 per year from 2030 onwards. So you could get 40 of those in position by 2050. But Tom Sampson, on a recent video he did for the IMEC, you can find that on YouTube. He says it's that production rate is scalable. You build more factories, so it could be quite easy for Rolls-Royce, if they can see the orders turning in, for them to bump it up to 4 per year. So by 2050, we could have 80 in place. And it's that kind of proposition that could get the UK to the top table again in terms of being a real nuclear power authority and industry. And I think that's a target well worth going for.
And can I comment on that, please, Ian? Colin, you're absolutely right. UK, as I said to you, is an advanced country. We're way ahead of the rest of Europe in the nuclear technology and everything else in the 90s until the privatization. And this is the whole idea of the argument was to the government that Rolls-Royce should lead the way and get the UK limited again, top of the table in terms of nuclear production and it can be done here in a scalable value position. And as I mentioned to you, I think, I don't know who put the order, but the Sheffield start manufacturing the critical component for about 16 reactors now. We're starting very soon. So everybody is very optimistic about the UK in terms of meeting its target for zero emission by 2050, you know. So I have no doubt about the UK. I was talking about the wider picture as well, because it's important to keep the wider picture in mind as well.
Can I just leave you for a second, Eric? I just want to put a question to Colin and to Mamdouh about the future, because as I see it, the future will be one where you have a large number of variable generators, wind power and solar, with some kind of dispatchable power coming from nuclear reactors. And if you're in that kind of, depends on the way it's regulated, particularly commercially regulated. But if you're in that kind of world, the kind of dispatchable power you want is one that itself can be varied. And my understanding is that the Rolls-Royce reactor will not follow power, that it's basically designed to generate constant power. Is that right?
I don't know, Ian, about that one, but it's historically from day one, whenever I studied nuclear and the economics of it, it's a base load. Ideally, nuclear should be the base load continuously. And well, the variable power is topped up by other components. But having said that, Sizewell, which is the biggest plant at the moment, is a full load follow. It follows the load, and I'm trying to Afro. I can't remember what Afro stood for, but I was there at 5 o'clock to do some investigation at Sizewell because it's the 5 o'clock people switch their kettle on. And actually, when they switch the kettle on, you can hear the reactor click, click, click in the control room, changing its position because the demand has changed significantly. So I think it's one of the requirements now, most power stations, including the very big one in Hinkley Point C, should be a load follow. So I am not sure about Rolls-Royce if it's load follow or not, but I'll be very surprised if it isn't.
Perhaps Colin can answer that.
Yeah. I mean, the situation with the small modular reactors is it's a marriage made in heaven, is just linking them up to electrolyzers to produce green hydrogen. Now, electrolyzers can accept switch changes in electrical input in milliseconds, so they can load follow in the first instance any of these ridiculous spikes and troughs that you get with renewable energy. So they can follow on a daily basis, load follow on a daily basis, just by switching between supplying the grid or manufacturing hydrogen. Now, the manufacture of hydrogen is an absolutely unavoidable necessity to be able to decarbonize all of the sectors of energy use. So hydrogen production it becomes another revenue stream for a modular reactor operator. And the cost of electrolyzers is coming down to the sort of $300 down to the $200 per kilowatt level. So the extra cost for coupling up to an electrolyzer would prove to be a real financial success for small modular reactors. So that is the way forward for the UK from 2030 onwards.
Okay, Eric, you've been very patient.
Ian, could I just say we are 4 minutes over time? So
Right. Okay, can we just give Eric a chance?
No, I had my dinner and my cup of tea. I'm happy to carry on if you wish. I'm not hungry. So let's have Eric, please.
I think we should look at some new technologies which have been introduced in the recent years. Think of electric cars. Think of solar cells for electricity production. Think of windmills, and think of a few generations back on airplanes. Think of modern transport technology. There are lots of them, and none of them have been designed out from the beginning of looking at what the whole system is like. All of them have developed by some people discovering a niche, getting into that niche, getting it to work, and if it works well, it grows, and the whole regulatory system and the whole management system, the whole legal system around it grow up at the same time. What you are saying, I'm not a nuclear expert in any way, is that small modular reactors are such a phenomenon which could become a major player. So I would hope that some of the people who really know that find design reactors, just as Elon Musk started with his most expensive Tesla cars. Find a model which you can sell in niche markets and then let it grow from there. You will find that as your productions go up, not from 2 a year, but say 2 a week, get the markets, find a way of getting into them, and then see how the things develop. You do not plan the regulatory system from the start. In airplanes, it's the Federal Aviation Authority, the FAA in the US, which basically leads the world, and there's no legal arrangements that they have authority of planes elsewhere, but the people there just follow. I think there is a need for people to get moving and to see if it works. My impression is too that from what you are saying, there is a real niche, but nobody has ever yet gone into it. But it needs to be thought through by industrialists and not so much by scientists. Scientifically, it's all right, but if you can get it to work, you need the Elon Musk of the small modular reactor.
Thank you.
Okay, well, I think Eric more or less summed it up quite nicely for us there. Thank you. I guess we probably need to finish at this point. Thank you very much, Mamdouh, for leading a really interesting discussion. I'm sure everybody's had new insights. Did you want to say something, Andrew?
That was a clap emoji.
Okay, all right.
No, thank you. It was a pleasure. So thank you to all.
Thank you very much indeed. We'll call it a day there.
Excellent. Thank you very much.
Thank you. Bye-bye.